Okay, good morning. Thank you all for being here on the last day of the conference. It's great to see that so many of you showed up. Today I'm going to talk to you about Analytics in the Box, how to accelerate the deployment of your next modern data platform. And first, a little bit about me. My name is Amy van Bijsterveld. I'm from the Netherlands. I work for a largish IT company. In the Netherlands, it's large. Well, compared to US size, it's not so much, I guess. And I work as a consultant, so that means that I work for smaller companies mostly in the financial and healthcare domains, and I help them set up data platforms, but also ETL pipelines. So basically everything a data engineer does, but then on a consultancy basis. And you might be wondering, like, this is a conference mostly aimed at data professionals, right? So why would I be talking about infrastructure? Because that's basically what we're going to talk about today. And let me show you something that I think really justifies the fact that I'm standing here for you today with this topic. This is a representation, and I will show you in a minute what it means. But in 2024, a survey was conducted, and it's conducted every year, but they asked data professionals, and that can be BI analysts, but it can also be data engineers, data architects. They asked them, like, what do you do on a weekly basis? How much time do you spend on certain things? And what they found is that 55% is spent on maintaining or organizing data sets. I didn't think that was a huge surprise because that's basically most of what we do. 13% on building reports and dashboards, which I thought was a little bit low, but then okay, fair enough. And 26% was spent on maintaining platforms or infrastructure. And then 6% is other, I don't know, coffee breaks perhaps. But 26% is maintaining platforms and infrastructure. And I thought that was a pretty huge number. Because if you work 5 days a week, that will be one whole day a week that's spent on maintaining the platform you work with. And I don't know about you guys. Any of you recognize yourself in this number, 26%? Can we show of hands perhaps? Okay, fair amount of people. Yeah, me too. And actually, sometimes I feel like it's even more. Because, especially with, software moving to the cloud, and when something is wrong, then, you're really stuck, You're dependent on cloud providers. You're dependent on the knowledge and the skills of people who build or maintain the infrastructure for you. So yeah, that's a pretty huge number. And I want to talk to you today about a couple of things. First, a little bit about platform engineering, the concept of what it is, some core data platform elements, which we will then translate to Azure services. And the key to success in this whole talk is infrastructure as code and how to use it in a proper manner. I'm going to do a demonstration, of course, some considerations for you to take into account, and some lessons learned. And of course, a little bit into a glimpse into the Fabric future, and some takeaways. So platform engineering, anyone already familiar with this concept? Okay, a couple of people. So basically what it is, and this is, there's a couple of different descriptions to be found, but one of the things that Gartner has to say about it is that it aims to unload the burden of the developer and, having this platform in place and maybe a platform team that deploys the platform for you to work with, so that you as a data professional don't need to worry about the underlying infrastructure, but can just focus on delivering business value, right? Because business value is what makes our employers happy. Business value is getting insights out of the data in your platform and getting the data there in the first place. So also what it is, and the prediction of Gartner, is that 80% of large organizations, and that's by 2026, so it's not that too far off, will establish platform engineering teams in order to make this work. So they'll have dedicated teams of people, mostly people who are trained as an infrastructure engineer, who know how to build and maintain and develop these kind of platforms, and they can distribute it among their organizations and people that actually need to work with it, so that the responsibility of the maintenance doesn't lie with the data professionals in our case. In 2022, it's only 45% of large companies that has these kinds of platform engineering teams. So it's bound to be a pretty big deal. And I want to tell you a little bit about how I got into this, because, like I said before, I'm a data engineer, so why would I get into this? Well, like I also said, I'm a consultant. So how that works is I get a call from my manager, and he says, "Hi, Amy, I got a new project for you. We have another client who wants a data platform." And then I'm going to go and I'm going to help the client, of course. And if I do a good job, then the client is happy. And then, I'll repeat that with a new client. Is this efficient? Not really, because that's me, right there doing that. But I also have lots of colleagues doing the exact same thing. They're building kind of the same data platform with the same concepts and components all over again. And the reality of that is that they all walk into the same problems and they're all trying to reinvent the wheel. Because it takes sometimes way too long to provision the infrastructure, like you said, and like you showed of hands, 26% of time is spent on maintenance, but also on developing the infrastructure in the first place. And that's mostly because of knowledge gaps, can be with people who are actually trying to provision the infrastructure, but also, a lot of change in our landscape, right? So a lot of new tools, a lot of new things you need to learn. So sometimes it just takes a long time to even get set up with proper infrastructure before you can actually start delivering business value. And even if you do have it set up, then it sometimes fails because of, unexpected circumstances, not enough people know how to maintain it. So this is what we see on a daily basis. That leads to project delays. It costs a lot of money because you need to hire maybe, people who understand this kind of stuff, or you need to train the people, or you need to invest a lot more. And the project is delayed, and that just costs money. So the question that we were faced, or that we actually came up with a couple of years back, is it possible, would it be possible to create like a standardized data platform in which we combine all our common knowledge that we've had over the last years, right? Because we work for different companies, so we get a lot of different viewpoints and perspectives, and then create like this standardized data platform, but manage it by a centralized platform team, so that all of our different clients don't need to worry about this setting up this platform, but instead we can do that for them, and make sure that if they have questions or if they have requests, they can come to us and we'll fix that for them. Because when you think about it, because then we started thinking about what would a standardized platform look like, right? Like I said, I work for healthcare domain, and I work in the financial sector. So imagine that there's a hospital and that's a bank. If we look at what is business value for a hospital, if you look at data platform, of course, it would be answering these types of questions. How many patients were admitted in April 2021, which is probably a lot because we're in the middle of COVID. But then for a bank, it would be, what is the average personal loan amount of our customers? That's what is business value. So basically, if we look at that, it's the top thing, for the hospital, that would be patient data that they need. And for the bank, it would be loan data. But underneath, you could really well have the exact same data platform to accomplish all that, right? So this is the things that we set as our requirements when we were developing this and thinking about how this would work. We needed it to be secure. That's really important because, like I said, financial healthcare, you can imagine the data being really sensitive, so it needed to be secure by design and also reliable. People count on having that data there in dashboards or for reports. And it needed to be based on best practices, both by the best practices set out by, for example, Microsoft in this case, when you're using Azure, but also based on our own best practices that we've come up with over the years, actually, as a company. It needed to be state-of-the-art because you're not going to invest a whole lot, because that would be an investment on our part to build this standardized platform for it to be, actually deprecated within a year after, putting it out there on the market. And it needed to be really fast to deploy because, like I said, if you want to ask a company to pay money for your product, it needs to be fast to deploy because, they want to start and have that benefit of, instantly being able to add business value for them. And also, it needed to be suitable for clients in different types of business domains. So not only financial or healthcare, my company does more than that. So also transportation, for example, mobility in public, lots of different business domains. And it needs to be scalable. And by scalable, I kind of mean two things. So not only scalable in the sense that we have resources chosen, or we have certain technical components, certain tech stack that can be scalable as a resource. So we can process small amounts of data, but also larger amounts of data, but also in a sense that, if we have to set up an engineering team, a platform engineering team, it needs to be scalable for them as well, right? Because you're not building like custom software, so you want to be able to have them help them manage the load of maintaining a platform for 20 different clients, for example. And I do want to give you kind of a heads up, like I'm telling the story about me working for a larger company, selling this as a product, but don't worry, today is not only about that, because the principles that I'm going to show you today are kind of the same if you want to do this, for example, within your own team or within your own company. But then you might want to, you don't have maybe a dedicated platform engineering team, but you can still use the same concepts and infrastructure as code to set up the platform. And so don't worry, and if you have questions in the meantime, just let me know. You don't have to wait till the end of the session if something is unclear. But first, I want to talk to you a little bit about building blocks of a modern data platform. That's how we started as well, thinking about, okay, a modern data platform, what concepts and what functionality should it have? And these are the 6 things that we came up with, or not just we, but this is something that's, basically underscored by many companies and many organizations. You need to have at least have something to be able to ingest new data. That seems fairly obvious, I think. Also, the processing of data, of course. Serving is like, serving it to your end users, which can be, just raw data sets if that's what they need. If you work, for example, with data scientists, they usually want just data, or maybe you bundle it in a data product, or it could be a dashboard or a report. And you want to be able to store all of that data. No surprise, I think, there. And you want some sort of governance on that. With governance, I'm talking about like data governance. And when I talk about manage, because these concepts are quite similar, but when I'm talking about management of the data platform, we're really looking at like how can I do access control properly, and how can I do logging and monitoring and all that kinds of stuff to ensure that I have a reliable data platform, and it's suitable for auditing purposes, for example. So that's what we kept in mind. Like when designing this, we wanted to have at least these 6 capabilities. And then also, you can argue that, for example, for ingestion and for processing as well, there's a couple of different things you can do. Of course, you have like batch processing options. So that would mean you get a large batch of data, maybe once a day or once a week. You ingest that into the platform. But also, for example, streaming ingestion, also possible, like near real time or real time, events being picked up by the platform, ingesting that into the platform. So there's a different variants of these as well, but these are the core components, really. Yes?
I've got a question, and I agree with everything that you've emphasized here.
Mm-hmm.
But generally what we struggle with a lot is that the users of the platform only really care about speed and reliability of the insights.
Mm-hmm.
Your sponsors or leaders only really care about cost.
Yeah. Mm-hmm.
But now you've got to attend to all of this, because as the data platform team, you know how important all of this and what else could go wrong.
Mm-hmm.
How do you manage all of that?
Yeah, that's a good question. So to repeat that and summarize that a little bit, is that basically you have a lot of different stakeholders in this process, and they all want different things, right? Or performance or cost, whichever you're talking to. If you talk to a manager, probably cost is important. If you're talking to an end user, probably performance is important. And we as people who maintain these and build these data platforms, we know that this is important. So how do you manage that? So that's a good question. So what we do is we deliver also the capabilities to make sure that, for example, cost, you can look into that. Like, for example, we have a cost analysis within the platform. And also, and I'll show you that in a minute, it'll become more clear. What we aim to do is we aim to provide the resources to be able to do all that, so to deliver performance, to deliver speed, but it's up to the data platform team itself to actually make certain choices within that. So we like kind of set out how do you call it, like boundaries. Like, for example, we made certain choices. Like, for example, the platform is serverless. That's a design choice that we made as the ones who designed the platform. But it's up to you, for example, if you use Spark within that, or if you use SQL within that, for example. So I'll show you in a minute, but let me know if it's not answered at the end. Then, actually, like, for example, I wanted to talk to you a little bit about generally cloud platform architecture. So this applies to data platforms as well. But for example, if you were to build an integration platform, we from our company, we have developed some sort of vision on what components should the platform in entirety have. So not just the ingestion and the streaming, but when it comes to observability of the platform itself, for example, or how you do CI/CD within the platform, we we have a couple of building blocks for that. So you see technical infrastructure, and by that we mean we understand networking, storage, compute capabilities, some runtime infrastructure. So this is where, you know, the observability and analysis happens. Some maybe web app hosting, which might not be applicable for a data platform, but for example, it is for an application platform, for example, and some orchestration capabilities. And then we come to the application infrastructure itself. And this is the layer that actually starts to impact the end users of the platform. So usually, like when you're working as a data engineer, I don't actually want to have anything to do with networking, right? It should just work from my perspective. But on the application infrastructure layer, that's actually where your end users meet the rest of the infrastructure, right? And then especially in the top layer, the application development, where we have, it could be definition packaging frameworks, but this is, for example, where your code is and where your ETL pipelines will be. And then we have a couple of supporting services. So we have pipeline automation, so that's CI/CD for the users themselves, so that they can go from, you know, go through the DTAP environments, but also maybe some custom repositories, for example. And then another couple of, you know, management services. So that's identity access management, a couple of, you know, things like key vaults, stuff like that you could share under this column. So I'm just wait for a little bit. Yeah, everyone took a picture of one or two, I think. So then I'm going to go back to this. You know, this is what I showed you before. And then keep that in mind, because then we started thinking of what part of that, you know, this picture can we actually generalize away? So which part can we make, a part of our standardized platform? And this red part, you know, outline bit, is what we actually made our standardized platform of. Because we thought, okay, basically, if we can do this, you know, you cannot, for example, generalize a top layer. That's so specific for the organization themselves. Because, for example, you can write an ETL pipeline and you can generalize certain properties of that, but then still the sources would be different, the sync would be different, for example, per organization. That's completely custom. But the bottom layers, 3 bottom layers, they're really something that you can generalize. And same goes for this right part and the yellow outline bit. And that's a little bit of a side note on that, because we made a kind of a distinction, because we don't think you can generalize everything that's in there. For example, if you want to build a platform, or you want to have a platform engineering team that maintains your platform, I don't want to be in charge as a member of such a platform engineering team that, for example, some users of your platform, there's something else, a new employee in the team, for example, and they need to have access to your data platform. I don't want to be, you know, handling requests all day of people who, you know, have new team members and can you add this and can you add them? That's something that's not, well, it's not really efficient and not really scalable. So the solution we came up with in Azure, for example, is that we, as a platform engineering team, we deploy the Entra or the AD groups, the Azure Active Directory groups, and the people who actually work with the platform, so the customers, they put the people with it in the groups. So then you have that distinction, and it's still scalable. But we, as, you know, platform engineering team, we can then still manage, you know, where everyone needs to access, because we work with these groups and the groups have access to certain resources, and it's up to them to just place the correct people in the correct groups, but then, you know, we can still make it secure by design. So just a little bit about, oh yeah, one question.
Sorry, quick question on the previous slide.
Mm-hmm.
On the pipeline automation,
yeah.
Wouldn't that lend itself very well to standardization and generalization?
That's a really good question. I'm just going to repeat that for the recording. Pipeline automation, wouldn't that lend itself well for generalization? That's actually something that we did. I'll show you in a couple of slides. We also separated that because you have 2 different kinds of pipeline automation. There's pipeline automation that the end users of the platform use. For example, if you build an ETL pipeline, which you want to maybe then deploy as an artifact from develop to test or to production, that's one part of pipeline automation. And the other part is us as a platform engineering team actually deploying the platform to our end users. And that's something that we also generalized. But maybe it'll make more sense in a minute, but good question. Yeah. Okay, so We then, we had this vision of what we needed our standardized data platform to contain. But then we needed to select like a tech stack. So no more concepts, but now selecting the right tech stack. Just a quick note, this was back in 2022, so there was no Fabric, there was no, there was Databricks, of course, but we had a couple of things that, we needed to take into account as well. We chose Synapse Analytics, maybe in hindsight, but still, we chose that because it has, Spark capabilities as opposed to, Azure Data Factory, which doesn't have that by default, and also low-code option to actually, make use of data flows and drag and drop. Because what we have lots of clients. They don't hire us for no reason, right? They need help with this kind of stuff. And what we see is that the level of the data engineers, the skill level of the developer at our client is usually not that, they're not really into programming. Maybe SQL, that's okay. But for example, talking about Python and using PySpark, that's where it gets a little bit difficult for them. Yeah. So, yeah, so that's why it was really important for us that it could be high code if you wanted to, but also there's support for low code capabilities. And also, like I said before, we wanted it to be serverless, basically also because of ease of use, because there's a whole lot of maintenance that if you were to, use a dedicated SQL pool, for example, there's a lot more to that. You need to go and index, and you need to do all the things that DBAs do on a daily basis. And that's something that's not really scalable and also not really necessary, to be honest, for the clients that we have in our portfolio. And also we needed it to be cost efficient, of course. Like you asked in the question before, cost is a really big thing because in our case, we were going to ask, this is a product, so we're selling that, so they need to pay for that, our clients, but also they have their own Azure bill, right? We're not going to pay that for that as well. So in order to, have this as a marketable product, you cannot price yourself out of the market. So it needs to be a cost-efficient platform so that the Azure bill is not too high and people actually see value in this. Also, we decided not to support stream ingestion, basically because there was not one customer who at the time who actually needed that. Because what you see most of the time, maybe if you work for larger companies, then this becomes relevant. But what we see most of the time is that it's okay if we ingest, for example, data on a daily basis. And it's also acceptable if that data is maybe maximum 1 day old and they don't need it near real time. So there was just no, if there's no client for it, then, we're not going to over-engineer just because for the sake of it. So remember this picture. I'm going to translate it to Azure services now. This is what we chose. So let's start at the bottom again, technical infrastructure. You see a couple of icons here. Maybe some of these are familiar. We see a couple of networking stuff, of course, virtual networks. We see, subnets, part of that, private endpoints, because like I said, we needed to be secure. Secure in our eyes was we're not going to use any public networking things. We're just going to do everything over private endpoints and private networks. So DNS, also kind of important. Storage account, we use Data Lake Gen 2 for most of it. Then some runtime things. We have Log Analytics Workspace. Part of that is Application Insights as well. We have cost monitoring. Like, I said before, we do have insights into, how much does this platform cost you. There's a couple of strange icons there as well. One of these is a self-hosted integration runtime. Lots of businesses actually still use that, and what it does is, in our case, why some people needed that, is they want a modern data platform, but their old platform or their current platform is, for example, is on-premise. So they use SQL Server, for example, and they have it running on-premise hardware. So they need some sort of, we need some sort of self-hosted integration runtime to be able to connect to the data for migration purposes, for example. Or it could also be a data source that is actually still, outside of Azure, and that's what you need a self-hosted integration runtime for in our case. And also you see the right icon is an Azure DevOps agent, because we also, part of the platform is that we also deploy an agent within Azure DevOps to be able to, be able for the people that work with this to deploy their software from Azure DevOps to the platform because, like I said, it's secured, so it's behind private endpoints. So you need some sort of agent in Azure as well to be able to reach the resources within the private networks. Then application infrastructure, like I said before, this is where the people that work with the platform really start to hit the infrastructure layers because Synapse Workspace is there. That second icon is something that I don't know. I think we developed ourselves, but it's Sparkpool basically. And then there's Purview. I'll come back to that because it's kind of a strange thing in this picture. Well, it's not strange, but I'll explain to you later. And then, application development layer, we see there a Synapse pipeline, a data flow, because like I said, low-code capabilities, a SQL script, Spark jobs, Power BI reports. For the people paying close attention, you don't see Power BI in this picture, but you do see Power BI reports. And that's because Power BI is not something you can just deploy using infrastructure as code, for example. It's part of the Microsoft 365, like you need licensing for that. And you cannot just easily deploy this like the other resources in this picture. But for example, we do provide connectivity to Power BI, so a Power BI gateway that's part of the platform, so that users don't need to worry about, how can I extract the data out of my platform and put it in Power BI. No, we provide the data gateway. They just need to, have a Power BI license, and we can connect that. Yes, question.
So I'm trying to understand why you still needed a Power BI gateway. Does that mean you were supporting cloud data sources and on-prem data sources?
Yeah.
ETLing directly into Power BI?
Yes.
Why, though, if you have the data factory and the Synapse pipelines?
I hear someone say, yeah, is that also?
No, I
Oh.
had a similar question, that the
Yeah.
stack is mostly for cloud data or hybrid,
Yeah.
but not like lift and shift.
Yeah, what do you mean? No, it's not for lift and shift purposes. Like we're not, like for example, VMs are not part of this platform because we're not trying to build a modern data platform and people can just, run their old workloads within the platform. That's not there. We really want to make sure that it's cloud native, actually. But we need a gateway because it's all behind private endpoints and to make sure that there's connectivity possible between Azure within, from within the private network to Power BI. We need the gateway for that. So that's basically the reason, yeah. But yeah, I see it.
Standardizing on the VNet gateway or the legacy gateway?
I'm not sure actually. But I can check for you after the session. Yeah. Oh yeah.
It does allow certain stacks, right? It allows certain IPs to go to the public endpoint to do it.
Yeah, but
I think the VNet data gateway was more recent, I believe. The SDSU integrated.
yeah.
But SQLMI running behind the private endpoint, we always struggle in the beginning to avoid coming to on-prem
Mm-hmm.
for all these ingress and egress things. So only way we were able to get over it was to allow the service attacks from our behalf.
Okay.
And
Okay, that's
the data gateway was just more recent and that can be plugged into the whole layer.
yeah. Because I know.
We had a lot more struggle because we had Power BI running on a different, I would say, zone. They don't, and the data gateway never worked for us, and we had to completely migrate Power BI to the eastern region and then go out the cloud.
Oh wow. Yeah. Okay. Yeah, that's really interesting. I have some time to talk after the session about that because that sounds pretty interesting. So, yeah. Okay.
It's changing.
Yeah, it's really changing fast because I know that there's a couple of variants. When we started out, there's certain limitations. For example, when you use the VNet gateway as opposed to like a dedicated gateway. So there's, yeah.
So if you weren't leveraging VMs, where did you install your self-hosted runtime?
Yeah, that's the one exception. We use a VM for that, but it's not like it's only because of that. And we are trying to, for example, for agents, for example, we're trying to use containerized instances, Azure container instances for that mostly, because it's just simpler. Because VM needs hardening, for example, and a lot more maintenance. So whenever we can, we use container instances for other purposes. But the VMs that we do deploy for things we cannot, escape, they're just meant for this purpose. So the end users of the platform don't have access to the VMs to, for example, misuse it for lift and shift stuff, for example. They cannot do that even if they wanted to.
If I may have a follow-up, I mean, this session is so relevant because this is exactly what we set up a few years ago, and now we're in limbo with the fabric.
Yeah, I'm gonna get to that.
So how did you deal, one of our biggest frustrations was that the Purview, the scanning on Purview cannot use the same integrated runtime
Yep.
as that you've set up for pipelines. How did you handle that?
Yeah, that's what we did. We set up another one.
So there's no like trick that you found?
No, not that we found, and also, but in general, but I'll come to that. The use of Purview is another, I don't know, I want to hear more about that from you, but what we did is we made it, but I'm giving away a little bit of the session now, but we made it optional, because Purview, in my eyes, is still really a product that's still under development to actually be able to, gain as much from it as we wanted to. Because the governance-wise, I don't know about your experience with that, but what I see, like when I look at this from a developer perspective, I want to be able to see lineage, for example, and I wanted to be able to, and then it's, I don't know where Microsoft is going with this, because now it feels a little bit of more, for the end users and the technical, the stuff that we want to know is kind of mixed together, and that's what you, have to deal with. So it's not really, workable at this time. But I'm curious to hear more after the session about your experiences, because, Okay, so I'm going to move on to pipeline automation. You see Azure DevOps there, and you see Bicep icon there. And also, like I said before, we split up pipeline automation, and I said a little bit about before how we did that. But we did want to enable our end users to actually be able to work with not only just YAML scripts, but also Bicep. If they wanted to, for example, if you were to deploy a SQL Server, because that's something that we do for some of our clients that use this platform. Not everyone wants that, for example, because we wanted to keep it serverless, but we do have some custom requests now and then. But we then, you want to be able to deploy a SQL Server, but they have to deploy a SQL database on top of that, for example. So that's actually where we draw the line. So in order for them to do that, it needs to have Bicep capabilities. If they want to do it correctly, right? Because you can also click, but that's not what we're trying to do here. And then a couple of things about management and governance. You see here resource groups, key vaults, and also key vaults, we make a distinction there as well. We have one that the end users can use, an application key vault we call it, and then we have one that we store our secrets and credentials and all that kind of stuff in. So we have two separate key vaults. And then you see the symbol for Entra. Like I said before, we create the Entra groups, and they put users into that. So, and also a security monitoring symbol, because we have policies in place and stuff like that. So now I'm going to tell you a bit about how we made it work. Like I said, like management governance, it remains a shared responsibility. And, we also made use, because, we do get, and that's maybe something you'll recognize as well, if you give something like this product, this platform to your end users, and you give them too many freedom, and for example, like the VM we talked about earlier, if you were to put no restrictions on that, you can sign it on paper, they're going to break it or they're going to misuse it because maybe they don't know how or they think it's an easier way. Can be all sorts of reasons why they do that, but we wanted to make sure that it actually can happen, so we created custom Azure rules as well for certain, to ensure least privilege. So also secure by design, like I said, because we use private networking for all of this. And something else that's really important is that we do cost monitoring from a platform perspective, not cost control. So no budgeting on our part, because this is, a kind of a tricky thing that we needed to work out in the beginning. Because imagine, for example, the following scenario. There's a data engineering team who uses our platform, and they have a Spark pool running, but they don't actually understand how to use Spark. A lot of data engineers don't actually know how to use Spark properly because they don't understand the workings and the internals of Spark. So what happened one time is that this team that uses the platform racked up a huge bill because they scaled up the Spark pool way too much, which wasn't needed because they were just doing code that doesn't match with. So what happened is that, if they come and complain to us, we don't want to be the ones to say like, yeah, I'm sorry, we should have seen it coming, because we cannot see this coming, because you want to give them the flexibility to scale up and down, because sometimes you do have a legit reason to scale up your Spark pool, for example. So we provide insights and we do monitoring. So by that we mean if we see that a Spark pool or whatever type of resource is there and it's not being used or it's being used incorrectly because we see it racking up too many costs, we do a monthly report and we say, hey, we noticed this, so maybe you should take a look. So this is where we kind of draw the line when it comes to responsibilities. And like I said a couple of minutes back, like Purview, we made it optional, mainly because of the reasons that I shared before. And also because still, if you want to do this correctly, we believe that, and I myself as well, like data governance is not something that you're going to fix within your platform engineering team. It's an organization-wide thing that you need to, you need to have data stewards, you need to have, in order to correctly establish this data estate that Purview wants to work with, it goes wider than just your data platform team. So this is why Purview is optional. So when a new customer signs on, a new client, an organization, they can say whether they want Purview or not. Oh, yeah.
When you're talking about cost monitoring, we're talking about setting up thresholds and budgets in the portal?
Yeah, actually, yeah. So like I said, we don't do any budgets. That's what our clients can do for themselves if they want that. We just do the monitoring. So we send that data to reports, for example, and some dashboards. And we can give them insight into their costs, but it's on them. If they want to go rogue or wild and they want to scale up the Spark pool to size XL, it's on them, right? Because it's their platform. But we don't want to be responsible for that.
But how is that different than just somebody watching the portal?
What do you mean? Like why we would do cost monitoring?
No,
Or-
how does what is your added value in doing cost monitoring while somebody that can just log onto the portal and
Yeah.
set up budgets and thresholds?
Yeah, for example, that's a good question. Like I do have a couple of examples. We have different variants of this platform as well. So with another client that uses data platform, they also have an integration platform, and they had a service bus that was deployed for I don't know how many. It costs a lot of money to have that thing, and it wasn't being used at all. These kinds of things are usually not noticed. At least for the companies I work with, by the engineers, because there's not really a priority. If management is, not giving off signals like it's too expensive, then why would I, worry about the cost? It's usually the attitude of the people that we work for, because they're not large-scale solutions most of the time, so it doesn't cost a whole lot if you use it correctly. So. But some things, we want the added value is that we notify them because they don't look at it themselves. So that's, yeah. So I kind of understand your questions, because if I were part of that team, I would look into that and do a little bit of FinOps, for example. But the people we work for simply don't. So, yeah. Oh, yeah, question here, then I'll come up. Yeah.
I have a comment and then a follow-up question, right? So on your comment, we're having a tough time setting up a proper BI for BI environment, right? Where we have information products that give us proper insights. And for me as a data leader, I would like to get feedback, granular feedback in a single platform on the Power BI that I'm familiar with, right?
Mm-hmm.
And working with the logs in the environment is really tough, making sure that you can, set up a pipeline to move that into your warehouse and get proper feedback. So my question then is, does your solution offer that? Do you offer proper BI for BI, where you can give really insightful insights on how costs are being monitored and how all the meters are running and how all of these components are performing within the platform?
That's a good question, and actually that's a work in progress, because we recently started doing that. We're building default dashboards to give people insights into that. And also we're working on, remember the picture I showed you, and then the top layer, we're working on also making that more standardized, not completely, but for example, developing frameworks in Python that can be used with Spark. So it's kind of platform agnostic, because you could use it with Synapse, but you could also use it with Databricks. And then we send, from this framework, we make this kind of, a custom log is kind of the thing we're doing. And with that, and this goes further than this session, but we store it in a Delta table, and then we can make reports on that in Power BI. And we store, we actually log things like how many rows were processed, what was the time that it cost to process that, how many gigabytes are we talking? So that we can make dashboards on performance of the things we're actually building. So we're working on, expanding that. So, yeah.
That's true value, and that's what we need.
Yeah. Okay. One more question.
Is on the same as data custom dashboards.
Yeah. So that's I answered the Okay. Thanks for the questions. So yeah, we have our platform architecture now, right? So how do we deploy this? And that's where we get to infrastructure as code. How many of you have actually heard of this concept, infrastructure as code? Okay, quite a few. So to describe it for you, it is a practice of defining and managing infrastructure through code and automation. So we can actually make use of software development practices to deploy our infrastructure. So if you're not using infrastructure as code yet, really, I would really advise you to do so because you will see the benefits in a couple of minutes. Because what we can do with that is we actually build, reusable infrastructure components. So not only, it sounds nice, infrastructure as code, but basically it's infrastructure as text. So we define our components within code. So not only is it then, easier to distribute, but also it's documented, right? Because you literally write it in code what you're going to deploy. And automated infrastructure provisioning, I can automate this. I don't have to do a clickety-clack in the portal, for example. I can just, put this into scripts and I can make it, or it is actually by default, idempotent. So if I were to run the same script over again, it would yield me the same result. There's an asterisk, and I'm going to explain to you in a minute. I think someone in the audience already knows why. Also, it ensures scalability and consistency, because the same scripts I can use for client A, but also client B, or maybe different if I have maybe 4 different Azure subscriptions, one for D, one for T, one for A, one for B, for example. I have to deploy scripts 4 times, but then that's it, right? I press go 4 times, and then it's deployed. And also consistency. And by that, for example, I also mean that it prevents configuration drift. Because how many of you have faced the dilemma that, for example, you just set up your infrastructure correctly, and then someone, files a request, for example, I need to have access, and you need to open port 443 in a firewall, for example, something like that, or in a network security group. And there's an engineer that goes, okay, I can fix that for you. And he goes to the production environment and he opens up port 443 and then he closes the ticket because it's done. But then what about our other environments, right? So now we have, unknowingly perhaps, we have 4 environments of which one is different because one has that open port and the other ones don't. So by using infrastructure as code, you can actually ensure that all your environments and also within the environment, things stay the way that you want them to be. And we can make use of the software development cycle. And this is pretty important because when you do, like I said, clickety-click, there's no one who, except if you were to do that, for a person or for ICE principle, there's no way someone is going to be able to review the work you've done if you created a new resource. But if you put it into scripts, if you put it into text, I can make pull requests, I could do code reviews before I actually deploy anything. So there's that as well, and I can automate it, use CI/CD on that, lifecycle management. So that's pretty awesome. And now about that asterisks, that is about if I want to make it idempotent, and if I have what I put also prevent configuration drift, that goes for the declarative approach only. And I don't think everyone knows what declarative means in this context, so I'm going to explain this to you using an example. Because we have declarative infra as code and we have imperative infra as code. Imperative goes like this. I'm going to give it separate commands in a row, go to the coffee machine, pick up the glass jar, fill it up with water, pour water into the machine, all the steps needed to make a coffee. And then I finish with pour coffee into cup. I have my coffee, right? Do I want to do this declaratively? I do this. I want a coffee. Basically, I specify the end result that I'm expecting. That's the declarative approach. I'm not going to give it certain steps on how to get there. I'm going to let it figure it out on its own. I want a coffee. Just give me that. Because what happens if we use imperative infrastructure as code, which is totally legit, but sometimes you don't get to use declarative infrastructure as code. I'll tell you in a minute why that is. Then you run into this. What if, for example, the coffee filters, we run out of those? Well, my program shuts down because it needs coffee filters and it cannot make the coffee without it. So that's why declarative infrastructure as code is really powerful, because you specify the desired state and it will go ahead and it will compare it to the current state for you. So now if we translate this to Azure, Azure uses the Azure Resource Manager, which is basically a layer to which all kinds of commands, whether it be, for example, if you use the Azure CLI, use PowerShell in order to make a new resource or whatever you want to do, But also if you use Bicep scripts, I'm going to go ahead and tell you what Bicep scripts are in a minute if you haven't heard of those. But everything that you're actually deploying to Azure, if you're querying things, everything goes through this layer, an Azure Resource Manager, which is kind of like a shell around Azure. You can basically, well, not entirely, but kind of compare it to an operating system for Azure, kind of. So I can have a template, for example, containing my infrastructure as code. I can send it through the Azure Resource Manager, and it will actually yield me a storage account, in this case, a Synapse Workspace, and a key vault. So I only need to supply one template in which all of these is defined. So going back to our platform is nothing more than just a set of templates. That's it. That's what we're selling. Of course, also the added, services, like I said before, cost monitoring, resource monitoring. If they want a new, feature in the platform, they can let us know. We'll, do that for them. But basically, at its core, it's just a set of templates, advanced templates that we've developed, and we can deploy in a matter of minutes, hours to our clients' Azure environments. And everything is as code, and that's important to mention because what I usually see, right now I'm working for an organization, for example, they don't actually have bought this product, they want to do it all by themselves, which is a bold choice because they don't have enough people to do it, but but like what they do is they have some of their platform as code, and then they go ahead and they say, Amy, I've done, I did a new deployment, go check out if that's okay. And then I say, hey, I see this missing, can you fix that? And then he goes and he does click, click, click again, and then he forgets to put it back into the infrastructure scripts. So next time he does a new deployment, the same thing is missing again, and this happens over and over again. So if you choose to use infrastructure as code, do everything with infrastructure as code. That's really important, or it's going to be a mess. And like I said, it's mostly declarative. Some things can be done declarative. We have to use, for example, custom PowerShell commands line by line by line in order to do certain things because they're not supported by Bicep, the language that we're using. And Bicep, speaking of that, Bicep is a domain-specific language, which means that it's specifically developed for use with Microsoft Azure. It was also developed by Microsoft. And it's actually evolvement of ARM templates. I don't know if anyone's heard of that. And ARM templates are basically in JSON format. They describe the Azure resources that you have within Azure. So it can be a really large template, for example, describing, if we were to talk about Synapse, it can be a JSON object, and I have a really long script with all the possible options that usually you would click through, but then it's all parameters and properties within the template. And that's a perfectly valid way. If you use ARM templates, you can use that, and you can deploy those to Azure, no problem. But then a couple years back, a lot of developers, well, me included, it's just a mess to work with this because you cannot program in JSON. You cannot read JSON, well, you can read it, but if you have this long of a script, it's not fun anymore. So that's why Microsoft developed Bicep, which is more developer-oriented. So you can write, like we as developers want to see, with code, with linting, with all the developer tools that you need. You can write your infra as code scripts, and then you can deploy those, and in the background, and Azure manages that for you, they will be compiled to ARM templates. So it's kind of like a layer before ARM, and it's really helpful if you're a developer and you're just trying to set up scripts. And also, we have one question.
So, using Bicep, how did you make the decision to use Bicep over Terraform?
That's a good one, because now we're actually, with the team that we built this with, we're looking into new platforms, because Synapse is kind of, well, it's not officially deprecated, but, but now, it's sponsored by Microsoft, this conference, so I can't say. Shh, this is our secret. Yeah, but like your question is valid because what we're doing now is we're looking into, if we're going to use Databricks, for example, or Fabric, but either way, we want to base it, building on Terraform because back then we made this decision because we thought, it's just going to be Azure Stack anyway, so we might as well use Bicep. But now we want to be able to open, Terraform is, of course, cloud agnostic. So we want to be able to have the option maybe in the future to use AWS, for example. And we're also working on our own cloud, European cloud system, EcoFed. So we want to be able to make it, more future-proof. So that's why. But then, we had a lot of engineers who knew Bicep already a couple years back when we were developing this, so that's why we chose it. But yeah, we'll do it differently next time. Yeah.
Yeah, we started in Bicep and ran into lots of things it couldn't do, and
Mhm.
ended up having to PowerShell around them, and it was like, well, that's pointless, so let's go and use Terraform, and then
Yep.
we're having this same issue, we're having different issues with Terraform, so now we just do both.
Yeah, oh, you do both. Yeah, okay. Yeah, that's perfectly valid as well. But then you need, I think that's just maybe a struggle, at least it was for us, you need people who can do both Terraform and both Bicep. And you need people, the people that maintain this in the platform engineering team, they need to have not only infrastructure, engineering knowledge, but you can imagine if I am a data engineer on the other side, I'm using this and I have a question, usually these people, like I said before, they don't ask us to help for a reason. So they come to us, to those people with questions like, hey, my script doesn't perform. That's not a question that belongs to the team, but they need to be able to handle that and identify, like, is this a data problem or is this a platform problem? These people already need to know a lot of things. And for us, it was a decision, well, keep it easy, keep it Bicep, just Bicep. But now, with our experiences now, I totally understand why you chose to combine it. Yeah. Okay. And we deploy this in an efficient manner because I talked about scalability. But for example, for our platform engineering team, we need to be able to do this in a scalable manner. So of course you can, for example, use Azure DevOps. I wasn't in charge in making the decision of what GitOps practices we used, but for example, they chose Argo CD to do this with, which was originally designed for Kubernetes deployments. But it works fine for them. It seems to be working fine. I'll show you a screenshot in a minute in how they use that. But first, because we don't have that much time left, I'm going to do a little demo. Let's see. So I'm first going to show you a little bit of the scripts. I'm going to start the deployment, and it's not going to finish in time because we only have 10 minutes left. But I kind of want to show you, this is a PowerShell script because I'm going to do a deployment now. I'm not going to use Git Argo CD right now because that's not, I just want to do a singular deployment. So this is not too interesting. This is basically, it kicks off the scripts. So I'm just going to start it, and in the meantime, I'm going to walk with you through the scripts. So just need to... Okay. Okay, so I started the deployment, and I will check back on this in the meantime, because basically what I'm doing now is I'm going to kick off a deployment of the entire platform, and you'll see it starts, if it works, it will go and tell me that it's running in a couple of minutes. So in the meantime, and we'll see what this does, I'm going to talk to you a bit about how we structured the scripts. Unfortunately, I can't share the entire source code with you because we market this product, so I cannot put this on my GitHub, for example. Wouldn't be too smart, I guess. But I can walk you through some of it just to show a little bit of how we done this. So it's running our deployment, so that's great. We'll check back in the Azure portal in a minute. But for example, I want to show you a little bit about, you saw the picture just now about the layers in our infrastructure architecture. And you see these back here. So we have application infra, management and governance, runtime, technical infra. And we do have some generic modules as well. So when we look, for example, at the application infrastructure, we see Synapse Workspace, for example, and we have a Bicep file here. And I'm not going to explain to you how Bicep works because that would be, we need another hour for that. But I'm going to show you a little bit about, I'm going to see where was Synapse. Workspace is this private endpoints. Yeah, there's a lot of stuff in here, so. Okay.
When you do an overarching parameters file at the start that you edit before you execute.
Sorry, parameters?
So for your
Yeah.
parameters, like if you're in which environment you're doing, which client
Yeah.
you're at, you do just a short setting of parameters right
Yeah.
at the start that then use to build out the
Yeah.
convention.
Exactly. I can show you that right now, actually, because we don't have that much time left. So that's an important part of it. 'Cause right now, I have it in PowerShell script here. But this is not something, like I said, we don't use this for our Argo CD deployment. So it will be, for example, in a JSON file where we store parameters in, or in key vaults if it's a secret. But like we have these kinds of things. So we have all these different kind of parameters, and there's a lot of parameters. But this is what makes it scalable, right? So we only need these parameters in order to, deploy a generic platform, which is pretty cool. So I can go up to new clients. I can say, hey, give me your tenant ID, give me subscription ID, and I can deploy this for you. Of course, I need a little bit more. I need a personal access token for DevOps, whatever, lots of things. But once I filled these out, I don't have to change anything. It stays the same.
What RBAC access?
Sorry?
What RBAC, what Azure RBAC
Oh, yeah.
do you need set up in order to run this?
Yeah, what are Azure RBAC? So that's a good question. So we thought of the developer's viewpoint that they, from Synapse, because that's where they develop most of the stuff, they need administrator access within Synapse. So we distinguish between giving them rights to resources or within the resource. So for example, you can give them rights to, or you give them access to control a database, but we want to do that within the database, and not that they can actually delete the database or change properties, because like I said, we want to make this secure by design and least privilege. So yeah, that's kind of what we do. We do most of it with managed identities as well, where we can. If it's possible. Sometimes some clients do need, for example, on a Synapse workspace, they need SQL access enabled, so they need SQL set up. But most of it, like 98%, is based on Entra IDs, managed identities, service principals.
So the reason I ask that is that, different organizations set this up differently. In my organization, all subscription level access is controlled by IT.
Yeah.
And for the domains that do analytics, like my domain,
Mm-hmm.
you only have rights at resource group, right?
Yeah.
When I look at your script, a lot of this, I suspect, might need subscription level
Yeah.
rights, especially if you're going to set up
Yeah.
service principles and the like. So how do you enable clients in that situation? Because then there's a lot of dependency.
Yeah, what we do is we actually have like a service principal that is completely transparent for the client as well, which has, so it's not a user base, it's like actually a service principal, and that has subscription level access, because you need that in order to deploy all this. But that's the only thing that has that level of access, because we don't want to have God mode kind of access for people, actually, also not for our own developers. So they need, that's a security measure that we took. Well, it's a large story, but in any way, there's one role who has subscription level access for the deployments, but then the others is just, completely, Okay. But yeah, it's actually a fair point, because the things that we notice now, because we did a little bit of a proof of concept with Databricks, how that would work, and they have the same problems. It's just how it works. If you want to enable Unity Catalog, for example, you need to do it on. You need to have super admin rights. You need to have really on tenant level even, which can be quite a problem for larger organizations. Because which administrator would give just a random company access to all that stuff? But yeah, so that's kind of a big issue. Same goes for Fabric, for example. It's also same thing. So yeah, but I'm really running out of time, so I'm not gonna show you all too much, I think, because if maybe you want to stay here, but then I do have some of my presentation left. But my main point is we parameterize everything. This is still running. I'm going to show you a little bit of how it looks then in Azure Portal. So I deployed lots of it this morning, because we're not going to wait till, does it work? Yeah, okay. We don't want to wait until everything is deployed, but usually it takes around an hour to deploy the entire platform, just to give you some reference. And then we have domain description names. We give training in these in the use of this platform, so that's why it's called student. But for example, we have a hub which contains DNS, for example. We also have the option because we sometimes encounter clients, they have already third-party providers who set up virtual networking, DNS, for example, so the bottom layer, the technical infrastructure. So we also made it so that we can actually plug into that, and we don't deploy this hub, but we plug into their hub, for example. So that's something we made dynamic as well. So here's some, bottom layer stuff. The client, usually people working with the platform don't even get to touch this. But then we have some application infrastructure. This is where it gets important. It's still deploying the Sims workspace right now. But we have, for example, the log analytics workspace for the customer. We have some, like I said before, container instances. And also, if we look at networking as well, here's 2 key vaults, for example. And yeah, more networking stuff actually that's on the spoke level. If you have hub spoke, network architecture, network topology, some things you want to manage on hub level, some other things on spoke level. For example, each spoke has a separate virtual network. Some runtime things, so log analytics workspace for our general dashboards. Like I said before, like the question that was asked, do you have custom dashboards? Yes, we assemble those using these log analytics workspaces. And then some more technical infrastructure, so that's more networking. Lots of it is just networking. This is where the self-hosted integration runtime is hosted on, like we talked before. And just to give you like a little bit of insight into how this works, we have a deployment history here. And you see right now that it is deploying. So this is what I just kicked off. So it's now working on, that's called AI, but it's not AI, it's application infrastructure, just abbreviated. And you see, you got some history, deployment history here. So as I'm running out of time, I'm just going to go ahead with my presentation. If you want to see more of this, just don't be afraid to, approach me after the presentation, because it's kind of fun. Just to show you a little bit of how, we make this scalable. This is Argo City. So what it does is a real live screenshot of the platform, the actual Argo City that we use, blacked out the name of the customer. But basically what it does is we can sync to a repository, and we can sync on the other way to the environment of the customer, and we can, increase, we can do incremental deployments, and it will say if it's synced, out of sync, degraded. It can have all sorts of statuses. But this is basically how we make it scalable. So we have it in one overview for all different customers, and also for performance purposes, we split up modules, because if you want to do a redeploy and an incremental deploy because you have a minor change or upgrade, for example, you don't want to have to redeploy everything. That's just, or even not incremental deploy, it takes too long. It's just not necessary. So we can do it component by component, basically. So a couple of things to think of before you get started. I would advise you to name your resources wisely. And this sounds pretty simple, but think of this. A key vault, it has a globally unique name. That's just something that Azure requires because of the URL you need to actually come into the key vault. So like I said before, we have 2 key vaults. We have an application key vault and we have a technical key vault. So this is, for example, the first key vault I deployed, and now I'm going to deploy a second one. But how is this going to work? Like if I am working with this platform as a data engineer, how do I know which key vault is which? So that's kind of a challenge. So what we, for example, use to solve this is we use tags, just to give the customer more insights into where they're looking at. And at the same time, it can be easy if you're looking at costs, for example, to distinguish between, hey, what does it actually cost, what the user is using, and what the platform is using to support the platform itself. And also, it's something to keep in mind, and this sounds like a great sales pitch, perhaps, to do this standardized platform thing, but it's not always the right choice. There's advantages, like I said, like engineers can focus on the business value. You don't have to have that much knowledge of the platform within the team itself. You can actually outsource it, kind of. And it's supposedly cheaper to do it like this. That's something that we see, let's see if you want to train engineers to have all this knowledge and not just have it, when you do this one time, but you need to, for example, now with Fabric or Databricks, if I want to evolve my product first from Synapse to something else, I need to have, those skills and those hours to keep up with that. So it might be cheaper to just have some people doing this on a dedicated basis. But yes, however, it offers less flexibility. Because like I said, you can use Spark, you can use SQL, but we don't support, if you want to use a dedicated SQL pool, well, that's not maybe the right choice, because we cannot actually maintain that for you. And also, if you, for example, change your mind and tomorrow you want to start using Databricks, that's going to be an issue as well. there's just less flexibility because if I make a choice and if I'm gonna promise one customer like, hey, you want this feature? Cool. But then I'll have to, deploy it to the other customers as well, right? Because otherwise it wouldn't be standardized platforms. There are certain exceptions, but mostly this is how it works because otherwise it's not scalable. So one example, for example, it's a data exfiltration protection. It's a setting on a Synapse workspace and basically protects against employees gone rogue. So if I enable this on my workspace, and I can only do that upon creation, if I want to disable it afterwards, for example, for some reason, then I have to throw away the whole workspace and deploy a new one. So that's kind of big impact. But it's kind of nifty to have because it blocks unauthorized connections to the internet and other tenants. You cannot just create a private endpoint to another tenant, extract the data, and just copy all data from one to another. No, it protects you against that with this setting. But what some people then don't realize, and this is what happens if there's knowledge gaps, it limits your capabilities kind of heavily because and it impacts all users of the platform. Because pip install, so if you want to install a package on the Spark runtime, that's not there by default, it's not going to work because there's no connection possible to the outside. Same goes, for example, for Spark logging. If you want to send custom logging, not possible anymore. Well, there are things to work around that, but you need, for example, additional Azure resources to get there. So that means increased costs. And this is a choice we made for our platform because we value security over, the flexibility. But that's something that you have to live with if you, design a standardized platform. And also, like we talked about before, the landscape is changing. So you want to, if you want to build a platform like this, it costs a lot of time, costs a lot of money, costs a lot of knowledge. In March, we had this, last year, 2023, we had this platform in production with our first client. And then only 2 months later, Microsoft announces Fabric. So yeah, so you can imagine how we felt. Think about that before you go ahead and build your own platform. We do have a couple lessons learned. I'm going to go quickly because I'm really out of time. But it was great to have those questions and make it a little bit more interactive. So I think it's important to realize that you want to build a community because what happens if you only, if I'm a platform engineering team and I keep pushing new features because I have requests from other clients, for example, that want these features, the other clients are maybe gonna feel like, this is gonna, kind of push down my throat, if you know what I mean. Like, I don't want all these new things happening to my platform. So make sure that it's always a two-way street. Like, evaluate with the clients, like, hey, is this something that is interesting for you? But also let them in on the process, like why it's so important to actually have these new features, or for example, new upgrades. For example, if we upgrade a Spark pool, why is that important? Well, because the other one is end of life, for example. Because if you don't do this, you're going to get shadow IT. Because like I said, our platform is least privilege, but it's still the environment of the client, right? The Azure subscription. So if they want to go ahead and deploy a new Synapse workspace in maybe a different subscription, it's on them, right? If you want to do that, but you don't want that because you want a platform that they can use, and that's what what you intend. You want to manage expectations. So even if you're doing this within your organization, not like us that you go to other organizations to sell this, but even if you want to set this up for your own organization, I would advise you to use something of a SLA, a service level agreement, or at least a couple things on paper, who's responsible for what. Because we've been in a lot of situations, especially in the beginning, where it was just unclear for the client, like what is their responsibility and what is ours. And you want to prevent that. And especially if there's another third party involved. For example, like in our case, if we encounter clients that have already maybe a third party that makes sure that the technical infrastructure, the virtual networks are there, well then, for example, if there's an issue with the firewall or something else is going on, like whose finger is are they going to point at? So make sure that it's really clear who owns what part of it. And you want to prevent those gray areas. And also really important is, it sounds great, create a standardized platform, but what we've learned over the year, maybe a little bit more, is that it's just not one size fits all. Because what we see is that we have a couple of businesses, especially if you're looking at larger businesses that use this platform, it's perfectly valid to use Spark because it's large data sets, and that's what Spark is meant for. But we also have a couple of organizations that use this platform who use such small amounts of data that Spark usually brings more overhead than it brings value. So in those cases, I would now in hindsight say maybe, okay, why don't you use Polars, for example, just Python deployed in a container, whatever, there's other solutions. And maybe Spark gives you too much overhead, too much costs. So think about that, like who is my end user, who am I developing this for? And try to support all use cases or choose to focus on a specific one. And remember that there's advantages and disadvantages, whatever you choose. So it cannot just be all perfect. And a little bit about Fabric, because when Fabric was announced, it basically solves a lot of the issues why we created this platform in the first place. So all those different moving parts, all those infrastructure components, basically for Fabric, you enable a capacity, you create a capacity, and the infrastructure is just there, right? It's awesome. So this is basically, which really kind of got us thinking, like, okay, does our platform then still add value? Probably not. So that's why we're working on, version 2 of the platform. Because like we talked about before with one of the questions, we think that the added value is now shifting more towards the top layer, the application infrastructure. How can I create a standardized metadata framework, for example, to process my data? How can I, generalize CI/CD? Like you said before, we have, work in progress in order to have some scripts in order to have some, standardization there. But still, I would invite you to be critical of what your organization needs. It can be tempting to jump on the hype train and go, Synapse, so now we're using Fabric, or, are we using Databricks? But it's important to keep the end users of your data platform in mind. If it's still, you have users and you need low-code capabilities, it might still be a fair choice to use Fabric. But for example, I've been experimenting with a lot of open source tooling lately, Dagster, dbt Core, DuckDB, and those tools are pretty awesome as well, even though maybe you should evaluate always the total cost for ownerships, because also there's new challenges with that. But still, evaluate critically what you need and what your organization needs. So, to repeat, it's pretty awesome building these kinds of platforms. You learn a lot if you're doing this, but always be critical. Infrastructure as code, also pretty awesome. If you're not using it yet, I would invite you to really start using it because it prevents a lot of pain in the end if you're using a platform. And parameterize for scalability. If you're using this even for your own organization, you still might have different environments and it's still of added value to do this. And one size fits all does not exist. So critically evaluate the use cases of your platform. So thanks, that's it. Kind of run out of time, but so if you still have questions or feedback or anything, just come to me after the session. I'll be here. And also, if you want to leave feedback as well, I highly appreciate it. So thanks for being here.